Could you imagine being in two spots at one moment in time? Well, it turns out that the electron just might be able to do that. You see, physicists have always been wondering, what are we made of? What is matter around us made of? So we built our microscopes and looked closer and closer until we saw that everything, us included, were made of these tiny bulbs that we call the atom. We couldn't see inside the atom, but that didn't stop physicists from theorizing what was inside of them. A man named Rutherford came along and suggested that the atom was made of smaller things, a nucleus in the center, and even tinier particles called the electrons circling around it, like the Earth orbiting around the Sun. This was not entirely right, though. Later, a man named Bohr came along and said the electron can only orbit the nucleus at certain distances. This also was not correct. Finally, however, by building upon each model, we arrived at our current model, the quantum mechanical model, who we have de Broglie to thank for this. To understand this model, however, we first need to understand the difference between particles and waves. You can think of particles as something solid that you can hold, like this Lego minifigure here. I can hold him and I can touch him. Waves are the opposite though, like light. I can't touch it and I can't hold on to it. So if I were to throw two particles at each other, they would hit each other and act as we expect. But if I shone a light at a particle, nothing would happen. But something interesting happens when we look at it at the quantum scale. Take for example a metal atom. This is the nucleus, and this is the electron. When I shine a light with enough energy on it, the electron is ejected out of orbit and flies away. It's as if I had thrown a particle at it and it hit the electron out of orbit. This effect is known as the photoelectric effect, which was discovered by Einstein. The light acted as a particle. But wait, I said that light is a wave, so how can it behave like a particle? The answer? It has wave-particle duality. So while I cannot give you a particle of light, light in certain circumstances can act as a particle. So what does this mean? Well, de Broglie saw this, and he said that if waves can act as particles, then the reverse should also be true. And this is the basis for the quantum mechanical model. Remember how Rutherford and Bohr predicted electrons orbiting a nucleus in our atoms? Well, the electron is such a tiny particle that quantum effects have a profound impact on its behavior, meaning that the electron actually behaves like a wave in orbiting the nucleus, and not like a particle. Whoa! This means that physicists can't identify what the electron is at any given point in time. Acting as a wave, it means that the electron has regions of probabilities it can be in, and that it is in fact everywhere in the scale of probability at any given point in time. So why is this important? Well, the idea of quantum superposition, that the electron is everywhere at once within its cloud of probability, has given rise to quantum computing. By furthering our knowledge in quantum physics, we can better understand the world around us, and develop new technologies and discover new natural phenomena, and understand the secrets behind them.